Hey, this is Mr. James. In this video, we're going to talk about the difference between similarity and congruence. We talked about congruence a little bit in the past, but not so much similarity, and that'll be the focus of this video. As you're watching this, remember two things. Number one, to be taking notes, and to keep these notes so you can use them on a video check, on maybe an open note quiz, or perhaps on your homework. And number two, to be rewinding and to be trying practice problems as we go along. So pausing and trying those practice problems. So let's get started. What do similarity and congruence have in common, and how are they different? What I've got is some figures here. Some congruent figures off to the left, some similar figures in the middle, and some figures that are neither similar or congruent to the far right here. Let's see if we can generate some conclusions. What do you notice about the congruent figures? Well, the congruent figures are the same exact size. On the other hand, the similar figures are not the same size. But the neither figures aren't the same size, and they're different shapes. So you could say that congruent figures are the same size and the same shape, but similar figures are just the same shape. Let's write that down on our Venn diagram. So we have that congruent figures are the same size, whereas similar figures are different sizes. However, both figures, down here at the bottom, both figures, both congruent and similar, have the same shape, right? Similarity is same shape, although it has a different size. All right, what else can we notice about congruent and similar shapes? Let's see here. Well, these two televisions are congruent. They're the same size, same shape, but they seem to be rotated. Looks like similar objects can also be rotated, okay? So no matter whether something's congruent or similar, looks like we can rotate, we could reflect, we could translate, all those kinds of transformations we can do to either of them, except look at this. Remember dilations? Dilations, remember, are when you make something larger or smaller, that kind of transformation, when you can expand or contract it. Congruent figures, there are no dilations here. No dilations. But similar figures, you can use a dilation on. Remember, dilation, again, means to expand or contract, make bigger or smaller. And looks like from this television to this television, there's a rotation, but also a dilation. So let's write that on our note sheet. So while both congruence and similarity have reflections, rotations, and translations, only in similarity can use a dilation. Again, that's where you make something, a figure, expand or contract, bigger or smaller, kind of like what we've got right there. What else can we learn about congruence and similarity? Let's see here. Let's look at these pair of figures. Well, congruent figures, all the sides and angles from one figure to the next are congruent. See, we have 1 centimeter, 1 centimeter, 2 centimeters, 2 centimeters, right? They're all congruent. And even the angles are congruent. We've got a right angle there. Right angle here, a right angle there. Everything is congruent here. Everything is exactly equal and the same from shape to shape. But when it comes to something like similarity, that's not always true. The angles are still the same. The angles are congruent. Notice they still have right angles, still right angles. But look at the sides. The sides are no longer congruent. They're different sizes. But they're different sizes over here, with the neither. So what makes similarity special? What makes similarity special is that all the sizes get larger or smaller in the same way. They're all going to be proportional. Here's what I mean. This side right here, to get from 1 centimeter to this side over here, you have to double it, right? Times 2. Same thing here. To get from this length, this top, to this new top, you're doubling. 2 times 2 is 4. We're doubling, which means we have the same ratio from this shape to this shape. However, over here, this is not going to be similar because even though it has the same angles, when we look from one figure to the next, these are congruent, 1 to 1, but these are not 2 to 4. That's not similar. So similar figures won't have congruent sides, but they will have sides that are the same proportion to each other. Let's write that down. So congruent figures have congruent sides. For example, these two figures will be congruent because their sides are the same exact length. But similar figures have proportional sides. What that means is that maybe this side of the triangle is 1 centimeter and this side of the triangle is 3 centimeters. And in this triangle, everything doubles. So maybe this is 2 and maybe this is 6. That means proportional. On the other hand, both congruent and similar figures have congruent angles, right? The angles have to be congruent from one figure to the next, both with congruent and similar figures. Let's take a look at another place where we might see kind of congruent and similar figures. Right here. These first two, looks like kites, are congruent. These second two kites are similar, and these third two are neither. Let's take a look and just figure out why that is. So these two first are congruent because they have congruent sides, 1 inch, 1 inch, 1 inch, 1 inch. They're congruent. And congruent angles, 120, 120, 80, 80. Those are congruent. But the similar shape won't have those congruent sides, 1 and 1.5, 2 and 3. They're not congruent, but they are proportional. Here's how we can check to make sure they're proportional, right? Check the ratio, or the fraction, of 1 to 1.5. So let's write that, 1 to 1.5. And if you divide in your calculator, you should get something like 0.666 repeating, right? Similarly, the ratio of this side 2 inches to this side 3 inches is 2 over 3. And if you divide that in your calculator, you also get 0.666, which means that these two sides, 1 to 1.5 and 2 to 3, are proportional. They have the same ratio when you set them up as a fraction. In addition, the angles are congruent, 120 and 120, 80 and 80. So the important thing to remember is that in congruence, both the angles and the sides are congruent. But in similarity, the angles are congruent, but the sides are proportional. One last thing to talk about, and here it is. Okay? When we talk about two shapes that are congruent, two figures that are congruent, we use this symbol right here, right? It's kind of like an equal sign with a kind of a tilde or kind of squiggle on top. When we talk about two shapes that are similar, two figures that are similar, we're not going to use that shape. We're going to use this shape right here. It's just kind of that squiggle or that tilde without the equal sign. Okay, this is it right here. And that figure, or that symbol, means similar. Let's write that down. And here we've got the symbol for congruence, and here the symbol for similarity. Let's try and use some of these properties to do some additional problems now. Number 2, complete the following similarity statements. Remember that the angles are congruent and the sides are proportional. So pause here and try and answer A and B. Alright, so what we have here is we have the similarity statement that polygon BCDA is similar to polygon FGHE. And this is going to work very similar to a congruent statement where the letters have to line up in corresponding order. Let's take a look at how that works in A. The measure of angle E is equal to what? What other angle? Well, if we look up here, okay, E corresponds with A. And we know, since these are similar, the angles are congruent. Angles are congruent, okay? And so E is going to be congruent to A because we're with the last letter in these similarity statements. So I'll write measure of angle A. There it is. For B, we have a ratio because remember, with two similar figures, the sides are proportional. They're not going to be congruent, but we can set up this kind of ratio. And so we have AB to EF, so AB over EF, is equal to AD over what? Now, AB, you can see right here, AB, first letter in this letter, looks like it corresponds to EF, and it should. These two sides should correspond, AB and EF. Great. So now, to figure out what goes down here, we have to look at the top, AD, these two, and figure out what that corresponds to. So AD corresponds to EH on the other polygon. So this will be EH. If we wanted to, we can even write more similarity statements, or ratios, just like these, using the similarity statement. For example, if I wrote down, let's see, BO, or sorry, that's BC, over, I have to use FG, because those are corresponding, is going to have to be equal to, and then you could pick any other two. Maybe CD over, and then what CD corresponds to, which is GH. Okay? So we can write ratios like this all we want about two similar figures as long as the numerator and the denominator of these ratios correspond, like BC and FG did in all these examples. Number 3, are these two figures similar? If so, write the similarity statement and give the similarity ratio. So let's take a look. To have similar figures, we have to have two things. Number 1, we have to have congruent angles. And number 2, we have to have proportional sides. Proportional sides. So let's check to see if we have those things right now. All right, here we've got right angles all around, right angles for right angles, which means the angles from this figure to this figure are exactly the same. They are congruent. Our first condition is met. We also have to have proportional sides. So how does that work? Well, to check if we have proportional sides, we're going to do is write a fraction with a corresponding side here to another corresponding side over here, and see if all of the ratios that we write are equal to each other. Let's see. So maybe 18 corresponds to 25. So let's write that down. 18 over 25. And maybe 15 corresponds to 30. 15 over 30. Let's see. Are those ratios the same? Well, 15 over 30, let's see, that simplifies to 1 over 2 if I divide both the top and bottom by 15. And 18 over 25, well, that has no common factors. So I can't really simplify that, can I? No. So 18 over 25, 1 over 2, those are not the same ratio. So it looks like maybe these two figures are not proportional. Maybe their sides don't have the same ratio. But wait a second. Maybe I've just written this ratio down incorrectly. Maybe 18 doesn't correspond to 25. Maybe 18 corresponds to 30. Wait a second. Let me erase my old work and try writing this a little differently. All right. So what if 18 corresponded to 30? Okay. And 15 corresponded to 25. 25. All right. What if that happened? Well, let's see. 18 over 30. Does that simplify? Well, let's see. I could probably divide both the top and the bottom by 6. And so let's see, 18 divided by 6 gives me 3. 30 divided by 6 gives me 5. And then let's see, 15 over 25. Let's divide the top and bottom by 5 this time. It gives me 3 over 5. So wait a second. Now when I line the sides up in this kind of way, I get 18 over 30 is 3/5. 15 over 25 is 3/5. What does that mean? Well, that means that the sides are proportional, and that this figure is proportional to this figure, which means that, yes, they are similar to each other. So since they're similar, let's do the second part here. Write the similarity statement. That's just asking you to write down how these two are congruent, or sorry, how these two are similar. So KLMJ is similar to, and remember we've got to line this up, so what would KL correspond to? Well, KL wouldn't correspond to OP, because you can kind of tell that this shape is a little bit rotated. So KL would correspond to PQ. So KLMJ is similar to PQ, and let's keep going around, PQNO. That's my similarity statement. And then the ratio is just the ratio of all the different sides. We figured out that 18 to 30 and 15 over 25 are all the same as 3 over 5. So my ratio from the smaller rectangle here to the larger rectangle here is 3 to 5. 3 to 5. Or you could also write it as 3:5. Let's look at this last one here. We've got these two shapes, and so remember, first thing we need to do is check to see if the angles are congruent. So 100 degrees here, wait a second, 95 degrees here, no way these are going to be congruent. They don't have the same angles. We don't even have to check the proportional sides. We can just stop and say these are not similar because the angles are not congruent. Not similar because these angles from one figure to the other are not congruent. This ends this video. We'll do the back in class. I hope you've learned a little bit about similarity and congruence.